Alright, good day students. I'm Mr. David and I'll be taking you mathematics. And this lecture is brought to you by Isaac Material Foundation. So today we'll be looking at plane geometry. Looking at plane geometry, also known as plane shape. Well, you might be familiar with this topic, that's the plane geometry, but we just have to do a revision on that. So what then is a plane geometry, also known as a plane shape? The plane geometry actually is the mathematical study of figures on a two-dimensional plane. I repeat, it is the mathematical study of figures on a two-dimensional plane. So what does that mean? So let me go straight to the point here to give you the types of the plane shape on plane geometry. So those shapes that are actually on a two-dimensional plane. So the first one is the triangle. So we have the triangle, okay. Then we have the rectangle, Then we also have the three. We have the circle. So also a plane shape, okay. Then we also be looking at number 4, which is your parallelogram. Then number 5, we'll be looking at your rhombus. Okay, then number 6, we're looking at your trapezium. Okay, so these are examples of the plane shape we're going to be dealing with under the plane geometry. Okay, so the aspect we're looking at is how to find the areas, the perimeter, exactly the areas and the perimeter of this plane shape. So let's take a look at the first one, which is the triangle. Okay, so a triangle looks like this. From the word triangle, simply means consists of 3 angles. Is that clear? 3 angles make up a triangle and also consists of 3 sides. So let's take this to be triangle A, B, and C. Mind you, whenever you want to represent a triangle in a mathematical form, you can use a symbol that looks like a delta. Okay, then you can write A, B, C. So mathematically looking at it, so understand that this means triangle ABC. So these are the vertices of the triangle, the 3 ends. So as you can see, we have the first angle, and here we have the second angle, that's angle B, and here we have the third angle, that's angle C. Alright, so this is a triangle. So, what are the types of triangles we have? The first one is your equilateral triangle, which you're familiar with. And the second one is your isosceles triangle. Okay. Then the third one is your scalene triangle. Then the fourth one we have your right angle triangle. Alright, so these are the types of triangle we have. Okay, so what is the area, the formula to calculate the area of a triangle? Basically, you notice that the area of the triangle is written as half times the base times the height. Okay, so here can be, if you look at this triangle now, and you asked to calculate the area of the triangle. So we have point A, point B, and point C. Okay, so AB, side AB, this is called side AB, and this has to represent side AB. So you draw a stroke like this, straight line, short one, and you write AB. This is side AB, okay. Then BC, side BC, this has to represent, this means side BC, if you want to write side BC. Then if you want to write side AC or side CA, whichever way, well, let's take side AC. AC is going to be AC. So these are ways to represent the side. Alright, now, any of the sides will be the base of the triangle. Any of the sides will be the base of the triangle. That is, AB can be the base of the triangle, depending on how it is drawn. BC can also be the base of the triangle. Then AC can also be what? The base of the triangle. But the formula to calculate the area of a triangle, it is what? Half base times height. Is that clear? Depending on the question you are given to solve. Okay? Then we also have another formula to calculate the area of a triangle, depending on the triangle. Depending on the triangle, beg your pardon. Depending on the triangle. So we have half A B sine C. What does the formula represent? What does it mean? Sometimes you'll be given a question whereby the angles of the triangle will also be given. Okay? Then how do we locate our A? Our A, that is A, then our B, then the side C, which is C represent the angle there. How do we locate this? Okay. So remember, look at the way I represented the side AB. That's side AB. Okay. So side AB, how do you represent it mathematically? Side AB, okay, will be represented with a small letter C. So this point here, this point C, that is facing the side AB, you represent here with what? Small letter C. Okay. Alright, so side AB is equals to C. Now, how do we locate our B? Okay. So you look at B now, then you ask yourself, which side is B facing? Which side is the point B facing? So we have A and C. So side B here, point B here, is facing what? A and C. So you represent here with small letter B. Okay. Alright. So the next thing is our A, which is the small letter A, representing the side. So which side is the small letter A? Definitely should know the answer that here it's going to be the side A. Okay. The side facing the point A. So these are the way to represent your side in the triangle. So to use the formula that says area of a triangle is equals to half A times B sine C. Now this actually represents an angle. Okay? Look at the way it's represented, an angle. So this represents the angle C. What if we have area is equals to B times C sine A. Okay? And we have area is equals to half A times C sine B. So when are we to apply this formula? Is that clear? Okay, I believe you understood this aspect. So now let's look at how to apply this formula when you are given a triangle. Okay, how to apply this formula. Alright, so assume you're given triangle A, B, C. This point A, this point B, and this point C. Okay. Alright, let me write it at this side of the board. Okay, we have A, we have B, and we have C. Okay, so the angle here is called the angle A. The back leg, the angle A. And the angle here is called the angle B. And the angle here is called the what? The angle C. The angle C. So in a question whereby you are given, now for the first formula, you are given side A, this is side A, okay, facing point A, and you are given side B, and this is side B, facing point B. Is that clear? Okay. Then you're not given the angle A, and you're not given the angle B. And you are asked to calculate for the area of this triangle. So the formula to apply is the second formula I wrote down here. So since you're given this side A and this side B. Okay, that's your AC and your BC. And the angle between the two sides given is what? Angle C. Therefore, you can apply the formula. Says half times A times B sine C for the first formula. Okay, first for the second. Okay, let me put it the second. Then for the third formula, you have a triangle like this. Okay, it's a triangle. Then you have A, B, and C. Is that clear? A, B, and C. Alright, and you're giving point B. Okay, that's side B, facing the point B, side B. Okay, and you're also giving the side C. I think here should be the side C. Okay, then for you to apply formula, you must be given angle A. This angle A. Okay, so this is where to apply the formula. Exactly. I'm going to apply the third formula. Then the fourth one is this, which is half A times C, then sine angle B. So you should have a triangle like this, a triangle like this. The fourth formula, a triangle like this. So we have here to be A, we have here to be B, and we also have here to be what? C. Is that clear? Alright. So you are applying half A times C sine B. So the point, this point C facing the side, is going to be C. Then this point A facing the side, is going to be what? A. Then you must be given angle B. You can see sine B, angle B. Is that clear? So we have angle B. Okay, I gave all these diagrams to make you understand better how to apply the formulas. Is that clear? Okay, so what we have there is different way the question can be given, and you have to know when to apply each of the formula given. Okay, I hope that is understood. Alright, so what can you deduce from the diagram given here? From the three diagrams, what can you deduce from the three diagrams? Then is this. If you are given a question and the examiner wants you to apply any of these formulas, he's going to give you two sides and one angle. Two sides and one angle, okay? So you might be given, let's say, side B, that's the AC, and side B, AB, okay? Then the angle between the sides is what you have to apply in the formula. So let's take a look at the first example. Okay, so we have some triangles on the board, different types of triangles as listed earlier. So we are to find the area of the five triangles. Okay, so the first thing to take note of is what type of triangle does each one represent? Okay, let's look at the first one. We have A, B, and C. Is that clear? A, B, and C. So to know the type of triangle it is, you have to check the sides if they are actually equal or not. Okay, so the first triangle, which is having 8 centimeter, side AB, side BC 8 centimeter, side AC 8 centimeter. So as you can see, all the sides are equal. So we call this an equilateral triangle. Okay. Then the next question we have this. Okay. From this now we have those two sides to be equal. Now when sides are equal, we use the same mark on them. Now look at the first example, the first triangle here. We have 1, 2, 3. 3 sides. We use just a mark to indicate that they are equal. So here we have 3 sides. Okay. So the side AB and the side BC are having the same mark. Just one mark, one mark. That tells us that they are actually equal. And the third side is having a double mark. That tells us that the third side is not equal to the other two sides. It's having a different value. So we have number 4 and we have number 5. They ask what kind of triangle is number 3 rather. What kind of triangle is number 3? This is a scaling triangle because you can see the different marks on the side. That shows that the triangle are actually the sides are actually not equal. Okay, so we have 5 centimeter, 8 centimeter, and 10 centimeter. All right. So number 5, we have the right angle triangle, where here is one of the angle happens to be 90 degree. Is that clear? So in the right angle triangle, one of the angles is 90 degree, and this is how we know that it is a right angle triangle. That's how to identify them. So question 1 says we have to find the area of this equilateral triangle. So if you look at this now, since all the sides are equal, so you can take any side as the base. Is that clear? You can take any side as the base. So I can take my AB as the base, my BC as the base, or my AC as the base. So we come here, okay, we have this. So we have A, we have B, and we have C. So I'm going to take my BC as the base because we have equal side. Okay, so here will be 8 centimeter, here will be 8 centimeter, and I'm going to draw a straight line, okay, a straight line to bisect this side BC into 2 equal parts. So here will be 4 centimeter, and here will be 4 centimeter. I want to ask, why am I bisecting it? Because we need to get the height of the triangle. So from here is 90 and here is 90. So from Pythagoras theory, just take 1/2. Okay, because here we'll be representing the height. So you're going to take 1/2 of it. So like this, like this, like this. So we have 4 centimeter, we have 8 centimeter, then we have 8. Okay, so let's find the height. All right, from Pythagoras theorem, okay, says the square of the hypotenuse side is equal to the sum of the square of the opposite and the adjacent side. Okay, so what we have here is that the longest side of the right angle triangle is the hypotenuse side, while the other 2 sides can be either adjacent or opposite. So from here we have 8 square, is the longest side, 8 square, the side facing the angle 90 degree, that's the longest side. Then we have h square, okay, then we have 4 square. So either this can be the opposite, this can be the adjacent. The same thing applies to the this side. The 4 centimeter can be the opposite, can also be the adjacent. Okay. So what do we have here? We have this will be 64, and we have it to be h square plus 16. So when you take this to the side, we have 64 minus 16 is equals to h squared. Okay, so h squared is equals to 64. Subtract 16 from 64. That will give us 48. All right, so h is equals to the square root. We're going to square root both sides. Okay, so you have 48. Then h is equals to the square root of 48. Give us what? The square root of 48. All right, we've got the height. So what is the area? And the area is equals to half times the base times the height. Okay, so half times what the base? Okay, any side could be the base. Okay, this is the base. The length of the base is what? Is actually 8 centimeter times the height. Okay, the height is what? Is 4 centimeter. What do we have? We have 2 and 2. Okay, giving us 2 times 8. That will be what? 16 centimeters square. So this is the area of the first triangle. Okay, so let's look at the second one. That's question number 2. Says find the area of this triangle ABC. Okay, 2 sides are equal, and the third side is having a different value. So what do we do? Alright, so this is the second question. Okay, 6, 6, 8. So we have an isosceles triangle. So whenever you're given an isosceles triangle, the longest side, okay, represent the base. Is that clear? Taking on the longest side. So if you look at it now, we have 6 centimeter, here to be 6 centimeter. So the longest side, which is 8 centimeter, represent the base. So we're going to have something like this, So it's going to be A, B, and C. So I'm going to turn it the other way around. So here going to be the B, okay, that's the B. Here is what? The C, and here is going to be the A. Okay, so BC, 6 centimeter. From B to C is what? 6 centimeter. Then we have AB to 6 centimeter. AB, that's 6 centimeter. Then we have that to be what? 8 centimeter. Okay, so what do we do? You divide the triangle into 2 to get the height. Okay, that's H. Alright, so here will be 4 centimeter, and here will be 4 centimeter. Okay, so bring out the right angle triangle. We have this, that's 4 centimeter. Okay, so we have 6 centimeter. Then we have H. We have H. So what do we do from here? To apply the Pythagoras theorem, it says hypotenuse square is equals to the opposite square plus the adjacent square. So what's the hypotenuse? The longest side, the side facing the angle 90 degrees. So we have 6 square is equals to we have 4 square plus the H square. Remember, this can be the opposite, can also be the adjacent. This can be the opposite, can also be the adjacent, depending on the angle given. So we have 36 is equals to 16 plus H, and we have square. So take this to the side, it will be 36 minus 16 is equals to H square. From here we have this minus 16 that we have, that's 20 is equals to H square. So H is equals to the square root of 20, and we have H to be, leave the answer in decimal, okay? So the square root of 20, and the value is 4.47, okay? Which is approximately 4.5 centimeter. So what is the area? Then the area is equals to half times base times height. So half. So what is the base? The base is the length of the top side, which is 8 centimeter. 8 centimeter times what is the height? And this is the height we got. Height is 4.5 centimeter. Okay, 4.5. So 2 in 8, that's 4. So it will be 4 times 4.5. So 4 times 4.5. You have 4 times 4.5. You have 18. 18 centimeters squared is the answer. So the answer to that is 18 centimeters squared. Okay. So let's look at the third question, which is a scaling triangle. Okay, a scaling triangle. So if you remember, I gave you our 4 formulas. The first one was the basic one, which is half base times height. Then the second one was for a triangle involving angles. Okay. All right. That is the half AB sine C, then half BC sine A, and half AC sine B. Okay. So those are the 4 formulas I gave to you. There is still one more formula, which is called the Hero's formula. Okay. It's called the Hero's formula. Now, the Hero's formula is only applied when the triangle is a scaling triangle, having on equal sides. Okay. So, how do we apply that one? Okay, let me put it this way. If we have a triangle, let me start with this. Have a triangle like this. Okay. So we have A, this point A, then this point B, and this point C. Alright, this, and this. So this point, this side facing the point is called A, this side facing the point B is called small letter b, and here is C. Okay, so we want to apply the formula. Right, to find the average of the three sides, which is A plus B plus C over what? Over 2. Okay, then after getting the average, then the formula says the area is equal to the square root of the S, okay, S minus A, S minus B, S minus C. So this is the formula to apply. Is that taken? Okay, so we have A is equals to the square root. So what do we have here? We have our A to B. We go to print to the triangle. So here is your A. Okay. Then here is your what? Here is your B. Okay. Then here is your C. Okay. All right. So we're done with this. Okay. And done with this. So the same thing applies to this question as well. So here is going to be your A. So here is going to be your B. Here is going to be your C. All right. So S is equals to A plus B plus C over 2. So what is our A? Our A is 8. So what is our B? Our B is 10. And what is our C? Our C is 5 over 2. So what do you have? There will be S is equals to 8 plus 10. That's 18 plus 5, making it 23. Okay, so we have 23. So 23 over 2. That will give us 11 points. 11.5. 11.5. All right. So let's find the area now. The area is going to be A is equal to. I'm going to follow this formula. I'm going to follow this formula here. A is equal to. Remember the formula is called the Arrow's formula. Okay. All right. So A is equal to the square root of the S 11.5 in bracket. So S minus what's your A? Your A is remember the S is 11.5. You still write 11.5 minus. So your A is what? 8. Okay. Then 11.5 minus your B. Your B is what? Your B is 10. And 11.5 minus the C. The C is what? The C is 5. Okay. So what do we have? A is equals to the square root of 11.5. Then you use your calculator. Then we have 11.5 minus 8, and you get 3.5. 3.5. Then we have 11.5 minus 10, we have 1.5. Then we have 11.5 minus 5, you have 6.5. So you multiply everything and you find the square root. So we have 6.5, 11.5, that's 1.5, that's 3.5, that's what? 11.5. So we have 392.4375. So when you find the square root of this, okay, you find the square root of this, you will get 19.81 centimeter square. So this is the this is how we find the area of a scaling triangle, and that's the formula, the Arrow's formula. Okay, we'll come to the end of this section. I want you to try the question 4 and the question 5 with the formulas you will give you. Okay. All right. Well, nice time.